So here are the steps for word problems. The first thing you're going to do is write what you know and what is not known. Second thing you will do is define the variables for the unknowns. The third thing is to write an equation. Your next step would be to solve the equation. And finally, you are going to write a sentence and check your work. So let's take a look at some word problems, examples from section 2.3. So the first type of problems you might see are number problems. For example, one number is 3 less than another. Their sum is 15. Find the numbers. So the very first thing we're going to do is we are going to write what we don't know, and what we know and what we don't know. So what we do know is that one number is 3 less than another, and we also know that their sum is 15. What we don't know are what the numbers are. So we're going to start by defining what those numbers are. So I say, let x equal one number. Well, then I have to figure out, how do I write the variable for the other number? Well, if I look here, I know it says one number is 3 less than another. Well, if one is 3 less than another, if I let this one be x, then the other one is going to be x minus 3. And that gives me my two numbers. Okay, now what I also know is that their sum is 15. So if their sum is 15, I know that, well, what does it mean to be sum? Sum means add. So if I take the one number here, x, and I add it to the other number, x minus 3, the sum is the result from an addition problem, so that means equals 15. Now what I'm going to do once I've set up my equation is I'm going to solve it. So here I go. I know x plus another x, that's combining like terms. That gave me 2x minus 3 equals 15. Now I'm going to solve this, subtract 3 from both sides. My goal again is to get x by itself. So now I have 2x equals 18. Divide both sides by 2, and I'm left with x. Those cancel out. I'm left with x equals 9. Okay? If x is 9, did we finish the problem? And the answer is no. We only found one of our missing numbers. We need to find the other missing number. And we knew that x was 9. Then we have x minus 3 was the other number. So I'm going to stick in 9 for x, and 9 minus 3 gives me 6. This shows us that we're going to write our sentence. One number is 6, the other is 9. I am now going to check my work. Well, how do I check my work? I know that my thing said one number is 3 less than another. So I'm going to take my bigger number, 9. I'm going to subtract 3, and I got 6. Oh, there was one of my numbers. There's my other number. That worked. I also said that their sum is 15. Well, 9 plus 6 does equal 15, so it checks out. Another type of problem is age problems. So here's an example of an age problem. Tim is 5 years older than Joanne. 6 years from now, the sum of their ages will be 79. How old are they now? So what do we know and what do we not know? Well, we know that Tim is 5 years older than Joanne, and we also know in 6 years, the sum of their ages will be 79. What do we not know? We don't know Tim's age and we don't know Joanna's age. So we are now going to define our variables. And what you'll notice is your variables are always really going to be what you don't know. So I'm going to say, let x equal Joanna's age. Well, we know that Tim is 5 years older than Joanna. And that's why I decided to pick x for Joanna, because then I can write Tim as x plus 5, because I know that Tim is 5 years older than Joanna. So x plus 5 demonstrates 5 years older than Joanna. Now, what do we know? We know that in 6 years, the sum of their ages is 79. So that means in 6 years. So we're not thinking about right now, we're thinking about in 6 years. So I'm going to take Joanna's age now, and I'm going to add 6 years. And this says the sum. So that means an addition problem. And then I'm going to take the sum of their ages. So I need Tim's age. But I need Tim's age in 6 years. So x plus 5 plus 6 tells me Tim's age in 6 years. I take the sum of those ages, I add them together, and it gives me 79. So now I am going to take this problem and I solve it. We subtract 17 from both sides, divide 2 from both sides, and I get x equals 31. I'm not finished. That just gave me Joanna's age. I need to find Tim's age, so I'm going to have to go x plus 5 to find Tim's age. That's 31 plus 5. That gives me 36. I can write that in a sentence. Joanna's age is 31. Tim's age is 36. Check my answers. 31 plus 5 gave me 36. That checked out. In 6 years, Joanna will be 31 plus 6. Tim will be 36 plus 6. That gives me 79. That also checked out. Now, another way to look at this problem to help you set it up is to make a table. And if I look at a table here, I can say, hey, here's Joanna, here's Tim. Here's their ages now. This is going to be their ages 6 years from now. So I notice, hey, I called Joanna's age now was X. I knew that Tim was 5 years older, so he's going to be X plus 5. Here in 6 years, Joanna will be X plus 6. Tim will be X plus 5 plus 6, which is also X plus 11. I know that in 6 years, the sum of these ages, that means adding them up, is equal to 79. And so I can write my equation and solve it, and I'll solve it just like I did over there. So that is another way to see this problem, is to use a table. And I find that tables really do help students out a lot. And you'll see a pattern when you're doing tables, that usually what's going to happen is you're going to be summing this last column. So that is an example of an age problem.